Okay, so we are going to do some summary of some things that we learned from the lab with the emission spectrum whenever you're looking through the spectroscopes, and then also from the flame test. So you want to get out your fill-in-the-blank notes, and in the assignment that I posted for today, I also have some videos that I want you to watch that just help us understand what these scientists are doing and discovering. Remember, the key question that we're asking is, why do atoms emit different colors of light for different elements? We are concluding it's the electron that does that, but because it does emit different colors, does that give us any clues or indicators of how that electron behaves in the atom? Where it's at, how does it move, what does it do? Okay, so that's what we're trying to figure out, because remember, electrons are the driving force of chemical reactions. You change the number of protons, that's nuclear chemistry. Neutrons, nuclear chemistry. You mess with electrons, you're doing chemical reactions, and that's what we're doing this year in class. So in your guided notes, find this page, and let's start. If you need to push pause at any point, do go ahead. Let's start filling this in. So different elements are going to emit different colors of light, and you have been doing this in the lab. This is called the electron emission spectrum. So just to process what that is, we're looking at specific colors of light that atoms emit when they are energized. Again, I'm expecting you to probably push pause at some point to get this stuff in. And whenever we're looking at this, how does this emission spectrum relate to the electromagnetic spectrum? Well, just remember, electromagnetic spectrum is a series of waves that includes light waves, radio waves, and all the other types of waves. So not ocean waves, not seismic waves, but when you think microwave, radio wave, infrared wave, ultraviolet wave, gamma, that's the type, just natural light, what we see as color of light, whether it's white light or a colored light, that's the electromagnetic spectrum. So we're going to focus on the part of the electromagnetic spectrum that's visible light. So, we have all these other parts that are in here for you to fill in. So here we go from radio to micro to infrared to visible up here, right? And we're going to highlight those. That's our Roy G. Biv idea. Red light, lowest energy. Purple light, highest energy. Okay. UV light, X-rays, and then gamma rays. So whenever you look, we go from low frequency up to high. So long wavelength up to a short wavelength. Long wavelength up to a short wavelength. High energy down here. Low energy down here. High energy way over here with the gamma rays. Okay, what's the dangerous stuff for us? Probably X-rays and gamma rays, right? Even UV light can cause some damage. Radio waves are not going to cause damage. They're going through you all the time. So that's one piece that we want to wrap our brain around. But what we noticed is, if I go back to this, and we looked at those individual elements, they didn't give off a blur of color like the sun does. They give off specific lines, and that needs to tell us something. There should be some clue in there. Why is it when I look at hydrogen, I see specific lines? I don't see a blur of a rainbow. And that goes for every element. Every element has a fingerprint of light waves associated with it, like how you have a true fingerprint associated to help identify you. So atoms of elements have a fingerprint in the form of light waves. And this is really how we know. When you ask, well, how the heck do you know what's in the atmosphere of some other planet that you've never even seen? Or how do we know what has been, what's out in Neptune, Pluto, whatever? We're looking at light waves coming back. So they're trying to use that data and processing, looking at those waves and the specific colors of waves and frequencies of waves to process what elements could be out there. Okay, so that's how they do this. So whenever you guys look, remember there are dark areas in the spectrum, and those dark areas, those indicate the energies that we can't, that particular atom is not able to give off that wavelength. It doesn't give off, no matter how we energize it, sending electricity through it, we see that pretty light, it never can emit the wavelength of color of that specific spot. As opposed to what does the sun do? Sun gives us all colors. So it can emit every single wavelength. But when we look at a specific element, there's a lot of gaps. Okay, so this is relating to energy, just like how we just saw, in this graph. There's energy relationship here. Okay, where we see high frequency, short wavelength, that's a high energy. So we can make these relationships. So these are going to be places where energy just is not released. And we're going to process this with electrons. Okay, so whenever an electron jumps, and this is going to be some videos we're going to watch to understand this. When an electron jumps from from its excited state to its ground state, it's not allowed to release energies to jump in those areas where we see those dark lines. And we're going to, hang out in this concept for a little bit. Where we see bright lines, that's where those electrons are allowed to release energy. Okay, so they're allowed specific bundles of energy that they can manage and play with, so to speak. So the colored lines indicates to us quantifiable bundles of energy that are released when electrons move from excited states to ground states. Okay, so excited state in electron cloud that we're going to learn is farther away from the nucleus to its normal ground state that's closer to the nucleus. So it's really important that as you do this, if you just fill in these notes and you don't take time to watch the couple of videos, and I think they're really well done, it's not Zelensky up there talking, you will get a better understanding of what's going on. They literally talk about the emission spectrum that we just did and looking at those spectroscopes and spectral tubes and everything that's there, and to really start to process what we're looking at. So I'm going to not show this video while I'm recording this, but this will be one of the videos that you are going to watch. Alrighty. And then the rest of your homework is listed underneath today's assignment too. Okay, thank you.